Hello everyone, we are Team Alpha Coders. I am Partha Shankar from CSE. We have built this project, AI-enabled health and safety monitoring system for mining workers. What motivated us to build this is, every year almost 6,000 mining workers lose their lives in accidents globally. Studies show that almost 80% of those accidents are directly linked to fatigue and 40% involve some form of PPE non-compliance. The mining industry still relies on manual checks and self-reporting. That's not enough. We have built the miner monitoring system, an AI-powered solution that watches over miners in real time. Let's go to slide 2. In this, let's break this down simply. No engineering background is needed. A camera is placed at the miner's workstations. Our system continuously watches the miner's face continuously. It reads whether their eyes are dropping, whether they are yawning exclusively. It even estimates their heart rate and oxygen levels just from the video. A second AI model visually checks their safety gear, helmet, goggles, vest, gloves, boots, and automatically in real time. The moment something is wrong, a supervisor sees an instant alert. Nothing needs a human to press a button. It just happens. Everything is automated. Next, let's come to the technology stack. The backbone is the Python and Flask, a multi-threaded REST API server that streams live video over MJPJ and pushes metrics every 100 milliseconds. For face analysis, we use MediaPipe 478 facial landmarks per frame to compute EAR for eye state and MAR for yawning. For PPE detection, we trained a custom YOLO V8 model. The dataset was built and labeled on RoboFlow and trained on Google Colab, detecting all 6 items at almost 95% of confidence threshold. The front end uses chart.js for live rolling graphs and vanilla JavaScript polling the API every 100 millisecond. So here we can see that the system design. There is a webcam in the laptop and the data flows in the respective manners.
Hello
Thank you.
everyone, I'm Anupama. I will be continuing with the live demo session. As of now, we have three miners along with their mining IDs and shifts and genders. We also have the option to add new miners. So once I click on someone, I go to this web page where I can start the monitoring. The monitoring is now through webcam. So as soon as we open it, first detects whether a person is present in front of the camera or not. And the PERC loss, the fatigue score is done, calculated using the PERC loss, eye closure, blink rate, micro sleeps, and yawns. And in order to calculate blinks, we use eye aspect ratio. And for micro sleeps as well, we use eye aspect ratio. For yawns, we use mouth aspect. And for every 4 yawns, an alert can be visible here. All the alerts are sent to the supervisor's dashboard. So every four frequent yawns, an alert is set, and alerts for respiration rate and low oxygen levels. All of it is set using the alert threshold. So this shows the PPE status. PPE stands for personal protective equipment. Right now we have the training of helmet, goggles, boots, gloves, and vest. Here we can get a live demo of a dynamic graph along with timestamps. These timestamps, when we hover over them, we can see the time and what kind of a vital sign was observed at that particular time. Now we will have Maitri to explain more about the backend configuration of our app.
Hello everyone, I am Maitri. Let me explain exactly how the system decides someone is tired or in danger. We use the two key geometrical ratios. EAR stands for eye aspect ratio. This is the ratio of how often the eye is vertically compared to its width. When EAR drops below 0.21, the eye is considered closed. If it stays closed for 18 or more consecutive frames, that's about 0.6 seconds, the system registers a microsleep. Even the single microsleep fires an immediate alert. MAR stands for mouth aspect ratio. This measures how often the mouth is. A MAR above 0.50 sustained for 0.8 seconds with a control rate of change, that's a yawn. 4 yawns or more during a session, a fatigue score climbs sharply. The fatigue score is a composite. 45% comes from eye rate via per clause, 30% from yawning behavior, and 25% from respiratory rate. For vitals, we fire alerts when SpO2 drops below 94%. Heart rate goes outside 45 to 120 BPM. Or respiration leaves a range of 8 to 25 breaths per minute. All of this plotted live. The rolling 60-point chart updates every 100 milliseconds with a separate y-axis for fatigue, heart rate, respiration, and SpO2. So the supervisor can see exactly when and how the miner's health changed. Now my friend Nirmit is going to explain application, future, and conclusions.
Hello everyone, I'm Nirmit Amjan. I'm going to explain where this project can be implemented. This system is not just for mines anywhere. Humans operate heavy machinery or work in hazardous conditions. Where this applies: construction sites, long haul truck drivers, industrial right shift workers, pilots, air traffic controllers, even ICU surgeons. The key advantages is that it requires no wearable hardware. If a site already has cameras, and most do, this can be deployed immediately. It also generates auditable records, timestamps, level logs of every health event, which directly supports regulatory compliance and insurance claims. In the next slide, I'm going to explain future enhancements. First, a mobile supervisor app for real-time push notification. Second, wearable sensors fusion to cross-validate camera estimated vitals. Third, a predictive fatigue model using an LSTM to forecast exhaustion 15 to 30 minutes before it becomes dangerous. Longer term, cloud multi-site dashboards covering entire mine operations, voice alert systems that announce warnings through site speakers automatically, and its deployment on NVIDIA JetSet devices. So it runs fully offline underground with zero network dependency. Finally, I am going to conclude this topic. To summarize that what we have built, a real-time system that tracks 8 health metrics across fatigue, vitals, and safety compliance. It checks 6 PP items automatically using a custom trained YOLO V8 model. It updates every 100 milliseconds, the closest thing to instantaneous, and it needs 0 variables. This is not a prototype concept. We ran it live. You just saw it. Mine kills thousands of workers every year. Technology like this can change that. Thank you.